rocket has just lifted off from northern Japan, but it did not come from JAXA, a government agency, or a daring startup aiming to make headlines. Instead, it came from Honda, a company better known for its motorcycles weaving through Tokyo's streets, its compact cars traveling global highways, and its business jets flying quietly above the clouds. Honda has now entered the space race, and it chose to announce its arrival not with fanfare, but with precision and discretion.
The RA-2...
The rocket is known as Hopper, and it measures just over 6 meters in height while weighing a little more than a ton. During its first public test flight, it ascended nearly 900 feet into the sky before descending to land itself with extraordinary accuracy, stopping just 38 centimeters from its designated touchdown point. There was no live stream broadcast, no cheering crowd, and no fanfare to mark the occasion. Instead, the scene was defined by crisp winter air, a remote test pad in Hokkaido, and one of the most precise vertical landings ever achieved by a private vehicle outside the United States or China. In just 57 seconds, Honda achieved something only a handful of nations and companies have ever done. They joined a very short list that includes SpaceX, Blue Origin, and a few emerging Chinese players. But this was not a copycat moment. It was a calculated demonstration of what comes next. This test was not about making headlines. It was about quietly and carefully laying the foundation, the way Japan often does when preparing to build something that lasts. And before we break down exactly how this rocket works, why it matters, and where it is headed next, if you enjoy deep dives into underdog breakthroughs, game-changing aerospace tech, and missions most people have never even heard of, consider subscribing to Project Aerospace. We bring you the stories just before the world realizes how big they are. Japan has long been a quiet but consistent presence in space exploration. Its missions rarely dominate international headlines, and its space agency, JAXA, tends to prioritize execution over publicity. Yet behind the scenes, Japan has accomplished some of the most technically demanding feats in modern aerospace. The country was the first to successfully land on a fast-spinning asteroid and return a sample to Earth. This was a mission so complex that even NASA had not attempted it at the time. Japan also developed Kibo, the largest pressurized module on the International Space Station, and it has played a critical role in building next-generation lunar robotics. Its history includes a wide range of quiet yet groundbreaking achievements, from asteroid dust return missions to solar sail experiments and planetary impact probes. These are feats that continue to influence global research. Today, it is collaborating with Toyota to develop a pressurized rover capable of operating on the surface of the moon. Up until now, Japan had not entered the era of reusable rocketry. For years, that capability had been limited to a few aerospace companies in the United States and China. Japan had developed highly reliable expendable rockets through Mitsubishi Heavy Industries and JAXA, but it had yet to master the specific technology of vertical takeoff and vertical landing. This is a breakthrough that has redefined launch economics and opened the door to faster and more responsive missions. This is what makes Honda's recent test flight so significant. The vehicle, not built by a space agency, but by Honda's own research division, demonstrated stable vertical takeoff and precision landing in a single, uninterrupted flight. It is the first time a Japanese-developed rocket has achieved that level of control in the air, which marks a key milestone on the path to true reusability. The fact that this achievement came from one of Japan's leading automotive manufacturers rather than its traditional aerospace firms makes the moment even more remarkable. Honda's test was not funded by a government program. It was developed through private research and engineering, grounded in decades of work with combustion systems, autonomous guidance, and robotics. This demonstration was not designed to reach orbit. Its goal was to prove that the vehicle's core systems, including thrust vectoring, stabilization, and landing software, could perform reliably under real flight conditions. The result strongly suggests that Honda has not only built a capable test platform, but also laid the groundwork for new generations of flight systems. In aerospace, the moment a rocket returns safely to its launch pad, the conversation begins to change. From that point onward, the question is no longer whether the system works, but how far it might go. The rocket is called Hopper. It is compact and unassuming, measuring just over 6 meters in height and weighing approximately 1,300 kilograms. It is no taller than a delivery lorry, but its purpose is not to reach the stars just yet. Its job is to prove what is possible. It serves as a testbed for technologies that demand repeatability and exacting control. In its very first test flight, Hopper climbed nearly 900 feet into the air, stabilized itself mid-flight, and landed just under 40 centimeters from its intended target. Every motion was deliberate. From the ignition of its engines to the final soft touchdown, the vehicle moved with the kind of controlled grace that usually comes only after years of refinement. For a rocket flying in the public for the first time, it delivered the kind of stability that often comes much later in a vehicle's life cycle. Unlike many traditional rockets, Hopper is equipped with retractable landing legs that deploy moments before landing, absorbing shock and keeping the body upright. Its aerodynamic fins extend during descent, adjusting for wind and drift, and then fold away as the vehicle settles onto the pad. These features are not decorative. They are essential tools in the art of autonomous recovery. Hopper is not designed to carry payloads, at least not yet. It exists as a platform to test the fundamentals of reusable rocketry. Its mission is to master the difficult things first, such as flight stability, control algorithms, and hardware resilience. The entire flight lasted less than 1 minute, but during those 57 seconds, Hopper collected critical data. It demonstrated that vertical launch and landing could be achieved in Japan using domestically developed hardware and software. It also showed that Honda's engineers understood what makes a reusable rocket work. And perhaps most importantly, they showed they could build one, a fully recoverable vehicle that can serve as a stepping stone to future launch systems. At the heart of the Hopper is a propulsion system that combines precision control with simplified architecture. Honda has not released detailed specifications, but early observations suggest the engine uses a cryogenic liquid fuel mixture, possibly methane and liquid oxygen. This choice reflects a growing trend in modern rocketry. Methane is clean-burning, highly efficient, and can be sourced or manufactured on other planetary surfaces, which makes it ideal for long-term missions beyond Earth. During flight, Hopper's control systems perform continuous calculations to adjust for changes in drift, altitude, and orientation. These adjustments are handled by an internal suite of sensors and a flight computer that interprets and responds to data in real time. This allows the rocket to perform minor corrections in the air, keeping it steady as it climbs and descends. The control surfaces, such as the deployable fins, play an important role in this process. These aerodynamic elements are triggered mid-flight, stabilizing the rocket during descent and helping it to remain upright without relying solely on thrusters. Once the rocket lands, they retract cleanly into the body. While the vehicle's size and performance may appear modest, its purpose is not. Hopper is built to solve one of the most difficult challenges in aerospace: how to land a rocket safely, accurately, and autonomously. The team is not focused on reaching orbit yet. Their attention is on building a platform that can land exactly where it's told to land, again and again. This is how reusable rocketry begins, not with grandeur, but with consistency. Honda is not new to ambitious engineering. The company began in 1946 with motorcycles. It expanded into cars, then developed a light business jet that now serves travelers around the world. The same research and development division that produced the Honda Jet is now behind the Hopper. In 2019, a group of Honda engineers presented an idea. They wanted to apply the company's extensive experience in combustion engines, robotics, and control systems to the field of aerospace. Management approved the proposal, and within 2 years, Honda confirmed that it was developing both a reusable rocket engine and a small satellite launch vehicle. The motivation was not driven purely by exploration. Honda believes that future mobility depends on the reliable access to space. Satellite constellations are increasingly important for navigation, vehicle-to-vehicle communication, and environmental monitoring. For Honda, building a rocket is a way to ensure the system that powers their technologies on Earth can be supported and expanded from orbit. At the national level, this effort fits within Japan's broader vision. The country has committed to lunar exploration through partnerships with NASA and other international agencies. By developing reusable rockets domestically, Japan strengthens its position not only as a contributor to global science, but as an independent spacefaring nation with its own tools and technology. This is not a race to build the largest launcher. It's a methodical attempt to build something that is efficient, reliable, and repeatable. For Honda and for Japan, the future of space is not just about going far, it's about going well. The Hopper may wear the Honda name, but it is the result of collaboration across Japan's research and aerospace sectors. The project is led by Honda R&D Company, a specialized team within the company responsible for experimental technologies. This is the same group that created ASIMO, the humanoid robot, and the Honda Jet. Their mission is to explore mobility in all its forms, including those that leave the ground. The team works closely with institutions such as the University of Tokyo and partners with Japan's National Space Agency, JAXA. These relationships provide access to scientific data, testing infrastructure, and simulation models that accelerate development. Other companies are also making moves. Toyota has invested heavily in space technology, backing startups like Interstellar Technologies and contributing to projects such as the pressurized lunar rover. Mitsubishi Heavy Industries, long considered the backbone of Japan's traditional launch systems, continues to develop the H-3 rocket, which remains an expendable platform. What sets Honda apart is its focus on reusability and vertical integration. Rather than adapting space hardware from defense contracts or legacy aerospace firms, Honda is applying lessons from manufacturing, robotics, and consumer product design. The goal is not just to fly, but to do so with precision, cost efficiency, and scalable engineering. This makes the Hopper more than a technical demonstration. It is a case study in how Japan's private sector is beginning to reshape the country's role in space. While the Hopper's first test was a success, the path forward remains challenging. Honda has described the project as an experimental effort, still in its research phase. The company expects to make a final decision on whether to proceed with full-scale development by 2026. That decision will depend on whether the engineering hurdles can be solved within a reasonable budget and time frame. Scaling the rocket to orbitable performance would require more powerful engines, larger fuel tanks, and advanced guidance systems capable of re-entry from space. These upgrades introduce significant complexity, particularly for a company that is still new to the launch sector. There are also financial constraints. Honda has not released detailed funding numbers for the Hopper program. Japan's national space budget is considerably smaller than that of the United States and China. This limits the speed at which new technologies can be tested, approved, and deployed. Even among governments, reusable rocket development has proven difficult. European programs, such as Themis and Callisto, have faced repeated delays. Japan's own national efforts in this area have also struggled to reach the testing stage. Honda's progress is impressive, but the team is still far from operational orbit. The next few years will determine whether Hopper becomes a permanent part of Japan's aerospace future or remains a promising experiment. Honda has outlined a broad timeline for its next steps. The company plans to conduct further suborbital tests and, if those are successful, aims to develop a scaled-up version of Hopper that can eventually support small payload launches into low Earth orbit. The roadmap includes key upgrades such as modular fuel tanks, adaptive guidance software, and more powerful engines. These features are essential for supporting longer flight durations and more complex flight paths. Honda's engineering teams are also looking at ways to refine the rocket's thermal shielding and guidance precision, both of which will be critical when the vehicle begins operating at higher altitudes and velocities. In the long term, Honda's technology could support the launch of Earth observation satellites, environmental monitoring payloads, and communication systems. These capabilities align with the company's broader interest in climate tracking, global mobility infrastructure, and next-generation connected vehicles. Developing internal launch capabilities would allow Honda to create, manage, and maintain its own constellation of low Earth orbit satellites, strengthening its independence and technological reach. Some of the technology may also support future exploration efforts. Japan is an active participant in lunar exploration, and reusable landing platforms could assist with cargo delivery or robotic landers in the near future. While no final mission has been announced, the groundwork is being laid. Hopper's development is not a race against other companies. It is a deliberate process that prioritizes precision, sustainability, and adaptability. Honda began its journey by manufacturing motorcycles and later expanded into automobiles before developing its own business jet. Now, the company has quietly entered the space sector. Each transition in Honda's history has been driven not by sudden leaps, but by steady development and continuous refinement. The Hopper continues that tradition by fulfilling a very specific technical challenge while also symbolizing something far greater. It represents a shift in how Japan views its role in space and illustrates how private companies can contribute to that future. Where other nations pursue even louder and larger rockets, Japan has chosen restraint, intelligence, and meticulous care. In this instance, that approach means building rockets capable of landing precisely where they are intended to land. If you would like to follow the stories that will shape the future of aerospace, including the quieter revolutions that often occur out of the spotlight, please subscribe to Project Aerospace. We bring you the ideas, technologies, and breakthroughs that will define humanity's next frontier. Thank you for watching, and we'll see you in the next one.